Rewrites are sexy until you realize you've burned 6 months, lost momentum, and shipped nothing new. Today, we're talking about why iteration beats the big shiny reset button almost every time. All right, so data shows that iteration wins, but the ego often wants us to do a software rewrite. So why is that?
So I was just talking to somebody about this, and I think they said it so well. Legacy software, legacy begins, or a system becomes legacy when an organization or a person can't hold the whole context of the system. And so rewrites are a selfish act by development teams to get context back.
So you're saying developers are just intrinsically selfish?
I think so. Well, I think what happens is you have a system, you may be new to a team, the team is turned over, the system's old, you haven't worked on it for a while, and because the context isn't there, as a developer, you're like, oh my gosh, I don't understand all the nooks and crannies of this application, of this architecture, of this software. And so the easiest thing for me to do, because all it does is process payments, or all it does is, record, contact information for our sales team, we should just rewrite it. And I'll just rewrite it because that's all it does, one thing, and I can get the context back, and it's super easy for me to then manage and add new features to. And every time I get asked to do something and I don't have the context in this legacy system, it's like, I'm wandering around someone else's kitchen trying to cook.
I'm going to take a slightly different approach talking about this. I'm going to talk about it from a lens of design systems and how do you set up a design system on a project. Generally, when you're starting a design system on a legacy piece of software, you're starting from there's just been a lot of work that's been tacked on, and there's not all consistent, right? So like you start off with, hey, let's all of these buttons across the site are inconsistent, all of the typography is inconsistent, all the colors are inconsistent. Let's just create like a design system and like just make everything from scratch, right? Like that's how we would approach it. But that falls into a trap of you're just taking too big of a bite and on like changing it all. I mean, it feels good, right? Like it's
an exercise in control. Like, oh, I can just rewrite the whole system.
Right.
I'll re-implement all the design.
Right. Or if it's like moving in from like like if you say you were in Sketch before and now you're moving into Figma, right? Or you're like whatever the migration is. It like you said, it feels good. You feel in control. You kind of bring everything back. But then it just like there's no guarantee that you will find yourself in a better place. Like I don't know if we'll get into this a little more, but I want to talk a little bit about starting small. But I'm going to pause here.
It's funny though. I agree though. It is kind of an ego play because it feels good. It's working in legacy systems and having to backfill tests or add features. It's like hitting the gym, right? Like you have to put in like consistent work. It feels like a lot of drudgery, right? But I think it pays off the same way. Like if you can iterate and learn. But the shortcut is always the rewrite. And I don't know. It's
like a shortcut around the mountain,
right.
Through the river and over the woods,
right?
And whatever that whole song goes.
Totally. I've actually earlier in my career, I definitely advocated for a rewrite and paid for it pretty gnarly to actually do that and see it fail.
It happens like all the time, and it happens. Consultants do it, internal teams do it, young teams as they like get into the context. I just think the context is the right thing. Like why is the design across all of our products different, and I don't understand the context in that, and so I just need to like redo all of the design. Or why is this system written in this language and this one in this language and that one in that language? Like we just need to rewrite the whole thing. Or when I was at PayPal, we had a system, and there was like a multi-year goal of like microservicing it, and it was because the monolith was too difficult to manage, and I always kind of second guessed. The microservices were a good idea, or services were a good idea, maybe not like a full microservice implementation,
right?
But like the rewrite comes at the cost, and this was happened at PayPal, is like the rewrite comes at the cost of progress. you cannot rewrite a system and build new features. So what engineering teams will go say, they'll advocate to a leader is like, I don't have enough context to add new features. So I want you to let me not write new features for the next 6 months. Because then afterwards, I might be able to write new features faster. And that's like, it seems like a really, really risky bet on that a company can make to not, okay, we're going to promise no new features for 6 months while we get a net neutral system that hopefully is easier to manage.
Yeah, that literally happened to me at a startup I worked at. We paused all feature work for a year and we lost our competitive advantage.
Which is the reason, I mean, you can't rewrite a system or you can't refactor a system and add feature at the same time. But often if the rewrite's happening, like it means that the engineering team hasn't been making like forward-looking choices throughout the development of the system. And yes, at some point there are systems that get rewrite. Like there's nuance to everything, of course. But if you're writing good tests, if you're architecting a system well, thinking about that architecture, like you're enabling that system to change like in incremental parts and small pieces of it to change over time.
Right.
Rewrites are a huge stinky pile in a company.
So if you are in this situation, right, you can see the road coming up where somebody's going to start advocating for a rewrite, right? What do you do? Like, how do you push back on that?
I think I want to hear about design because I have like a really strong opinion on engineering, and I have like way less of an opinion on design.
Yeah. Plus, there's 2 engineers here.
Yeah, exactly. Maybe I'll let you talk first.
So I'm assuming the rewrite pressure is on the engineering side, not on the design side.
Could be on design. I'd love to hear that component of it. Yeah.
I mean, if you're talking about like redesigning things, something from scratch, I mean, it always starts, to me, it starts with, there has to be, I'm hoping there has to be a good enough reason for the design, for the reason for the design to happen in the first place. It could be, I mean, there's so many like what ifs, like conditions for a redesign. Like, is it the system laggy? Like, are the users are getting frustrated with a bloated experience? Is it slow? Are users having trouble finding or accomplishing those tasks? I mean, there has to be a certain threshold of user burden at which point a rewrite becomes necessary. But if there's core services that could be solved without rewriting the entire thing, then I mean that's an approach too. I've seen both, right? So at a previous company, we had a lot of trouble with people filing their taxes on their equity compensation for their stock plan, because a lot of people didn't realize that they would get taxed twice, once on the cost basis and then once when they actually get their shares released to them. And both educating them and building an experience that showed that clearly was a challenge. But it also fell under this company objective of increasing retaining customer share, because generally what happens is, like, as soon as an employee's shares vest, they would just move it to one of their personal brokerages away from this company, right? So it was like, how do we retain these assets and educate them on taxes and give them ideas in investing? I mean, this is a big problem to solve, right? And we started off with basically called it a planning center within the stock plan application. But then there's, and it was funny because we actually built this in Angular, but the rest of the company and all of the cool stuff that the company was doing, they were doing it all in React. And we were just trying to play catch up and, trying to mimic what the rest of the company was doing with our design in Angular.
Why'd you choose Angular? Do you know
that was the original stack.
Okay.
So the rest of the company moved away from Angular into React, and we were just still stuck in Angular, and they weren't really incentivized to move away from Angular because they demanded such a big portion of the revenue. They just were like, we don't feel like doing it, right? So as a design, we had to pull these guys forward and keep up with the rest of the company, and it was just an interesting exercise. I mean, we were still able to deliver value in that scoped our scope of the project, but doing a full rewrite, we weren't able to convince them to do that.
So I think there's like something. Yeah. So there's something. I think that it's like design represents the user, right? Like, and like, yes, you do designs, but at the end of the day, like your purpose in the three legs of a software team's stool is to be the like advocate for user experience. Right. And so when engineers advocate for rewrites, it's normally design's fault. And the reason it's design's fault is because design is intentionally ignorant of the technical limitations of a project. And this can actually cause huge problems because it can lead engineers to want to do rewrites. Because design will say something like, oh, we're hearing from users we want real-time information, or we're hearing from users that we want this to be more interactive, or we're hearing from users that we want it. And then design will go into Figma and they'll design some extremely beautiful, extraordinary feature that is like technically impossible in the current system. Like the limitations of the system just don't exist. We don't have real-time information. There is no push. That data doesn't exist anywhere. And so then what an engineer does is say like, well, we have to do what's good for the user, so we should rewrite the whole system.
Interesting. It's weird though, because again, I'm an engineer, right? So very ignorantly, I think rewrites are very constant in design, right? I mean, you go to like a e-com site and looks completely reskinned, like they've rethought the whole design thing. Like, I guess that I'd never thought of it as like this measured approach where it's, you don't just pause and, you know, you iterate and kind of change that kind of dynamic. I don't know. It's interesting.
And with design, we can also move fast and break things.
Right.
Like we're not tied to reality. Right. So,
usually not.
No. So we're able to think of, but I would say, you know, the responsibility for design is to defend the vision, right? Like you set a vision, you know what's good for the user, and I don't think you can blame design for, like, if you're advocating for the user and you know this is what the users want and it's going to be good for the company, for the users, like you can't put the blame on designers for kind of
well, so I had this
proposing that.
Right. I mean, kind of, you can, but we had this project, and we were designing a restaurant app, right? And so we're working with this big restaurant group, and first design engages. This wasn't you on this project, by the way. So I'm not like putting you straight in the hot seat. It's a totally different designer. But the designer went and built or designed a beautiful system, but where like the system had things like, oh, I can track my order and I can see, you know, where it is in the cooking process. And I had all these, and they presented it to the client, and the client was like, oh my God, this is amazing. And then engineering came in and was like, well, I'm sorry, let me splash some cold water on you for a second, because like you don't have the ability to see where orders are processing. You don't have the ability to see like to record ratings in this way. You don't have the ability to do that. So like those integrations just didn't exist. So design was able to create this like beautiful world. We're not talking about rewrites now. We're just like crapping on design, and I don't want to do that. What I think happens, so to bring it back to the rewrite, what I think happens is design doing their job well, which is advocating for the user, creates back pressure on a system that was poorly architected to handle the future-looking state of the application or desires of the user. And so what engineers do is, because there's like, I love the idea of like real time, because this happens all the time. This is when I see design or rewrites come in the most, or have seen, is like we use a solid database and it's like Postgres, and we get data from it, and then all of a sudden we start hearing information from users that we want to like push information in real time out. And so an engineer makes this decision. It's like, well, we have Postgres and it doesn't really do that, so we should rewrite the whole thing to use Kafka. And
now
you're kind of like
problems.
And now we have, yeah, exactly. And now we're going to do like an event-driven system, because then all of the stuff can be real. We're going to like do microservices, and we'll put events everywhere, and we'll have Kafka, and we'll catch it all in the middle, and we can like push all the information out. And what design needs to do, and what engineers need to do, and engineering leaders, because the whole question that you started with is like, how do you push back? Is like, no. What is the feature we're trying to fix?
Right.
When people want to rewrite, it's because they don't have context on the system. And if you write good tests, if you build good systems, if you have automated testing, continuous integration, low code ownership by an individual and high code ownership by a team, you can say, wait, instead of having like a full rewrite because you need context, we can focus in on a feature, change this one thing, integrate a new technology if it's Kafka or real time or whatever, and then what we can do is run the tests and make sure that the rest of the system works. And if the tests pass, we push.
Sure.
Then we don't need a rewrite to get there.
Right.
We solve one user problem at a time, and we drive that forward. There's huge incentives from these SaaS, like from products, to have you rewrite, which is, I think, part of the problem too. Like, they promise Nirvana, move to React and it'll be, all your problems will be solved. Move to Amazon and all your problems will be solved. Like,
right. We know that doesn't ever happen.
Yeah.
So I'm going to beg the question that if I anticipate maybe what the audience is thinking at this point, right? What's the question that I would want to know? Never rewrite? I never get to rewrite? Is there ever a good case for a rewrite? When, you know what I mean? Like, are we just saying we just iterate always? We never do a rewrite?
Kinda. I mean, yes, you can. Yes, there are times we rewrite. So when you build a system, you make fundamental bets on core technologies.
Sure.
And so, like, a fundamental bet on a core technology is like the language decision. It is maybe the core framework decision. So if I'm going to build this in Spring or in Rails or in Django or in React or whatever.
You're telling me if I decided PHP, I'm host?
Yeah, probably. Or it's WordPress. Most deployed language, worse to work with. I think, like, if one of those fundamental bets you made changes,
right,
then I think a rewrite is more appropriate than iteration. But the question is, like, so when I think rewrite, I think like whole system,
soup to nuts
to new whole system. So, like, Rails Monolith turned into Rails microservices.
Sure.
The question is actually what is demanding that rewrite. So, like, if Ruby has some issues or Rails has some issues with a feature that's coming out, or we need to do, can I instead carve out, like a surgeon, carve out a piece of that application and then rewrite a component of it in a new stack, new language, new thing, but the monolith can stay.
Sure.
And they can interact. And it's really easy to, like, say that here, and that's hard work, but it means that we don't have to, like, build a whole new system, because engineers constantly, they're like, oh, it'll be really easy to rewrite this. All it does is these three things. And then, like, there's decades potentially of, business case, logic, edge case, that is all, like, embedded in that system that they underestimate.
So you're saying that if I made, like, a core fundamental technology decision that needs to be augmented or changed, that would be one case for a rewrite?
Yeah.
I think the other one too, if your business has to pivot very rapidly, right? And so you have, like, a massive pivot on what you're doing for, like, a core fundamental, like, value stream, that might trigger a rewrite.
Yeah, but rewrite to me is like pause all features, do nothing for 6 months.
Yep.
And so if my business has got a fundamental strategy shift, pausing off, and I'm not saying rewrite in that case, it's actually just like a new build.
Okay, that's what you're saying. Yeah.
Like,
just consider it net new.
Rewrite is like the definition of refactor is to change code without changing its behavior. The way we know we're refactoring is we run tests, right? We know we change the code without changing the behavior. A rewrite is a refactor of an entire system, but the behavior doesn't change. Yeah. And that is what is that's what's sold as a rewrite. When I migrate my on-prem to AWS and I'm all cloud services, system's exactly the same as it was, but hopefully it's cheaper, or
probably not.
Or you can iterate faster on deployments, or I can dynamically scale. If, like, I'm going from Rails monolith to Java microservice, I want all of the boundaries of that system, all the user interactions, the API calls, all that stuff. The behavior shouldn't change. It's inside that black box the behavior changes. If your business is changing, like, throw the old one out and build a new one.
Build a new box. What about for design, Shahed? What do you think?
So I want to go back to what you called out, the back pressure that design puts on engineering, like to do the rewrite. And I mean, you kind of argued in favor of design, like kind of carving out sections of it.
Look at you go, man.
Yeah, I mean, that's a responsibility for engineering. I mean, design is responsible for user value, and engineering is responsible for viability and feasibility. That's the responsibility. It's design sets the vision. I mean, we can argue about, design having some understanding of, if this is possible or not. But I mean, if I take a real big step back, and I'll say, like, in the realm of physics, if it's possible, then it should be possible if design is proposing something. And we're only talking about software, right? If you're talking about, okay, yeah, we don't have the endpoint for this feature, you don't have the endpoint for that feature, like, all of that, I would say, is a responsibility of engineering to advocate on that, and splashing cold water on this is the right thing to do. You're supposed to say, yeah, it's not possible right now, but how do we iterate our way to that vision?
Yeah, that makes sense. I think it's like rampant optimism sometimes. Like you can't get the context. You're like, it'll be fine. We'll just rewrite it, right? Everybody assumes that there's like the human labor cost and all that. What are other costs, though, that you think of on rewrites?
Feature death.
Okay, tell me more.
I mean, we talked about it a little bit already, but it's like when I do a rewrite, I am not building new features.
Yeah, so that atrophy of like movement of your product, right?
Right, and like I'm going to the way it normally happens, or the way I've seen it happen, is like VP of engineering, CTO makes case, system doesn't work, to do what we need it to do. It's not going to scale in the way it needs to scale. Give us, CEO, or board 6 months of no features, and we're going to have this whole thing rewritten. 6 months becomes 9, becomes 12, becomes 15.
Yep.
New features have to get done at the same time. There's drift in requirements because we're adding new features to the old system. We kind of need to bring those into the new system. So we're chasing a moving target, and whole swaths of engineering effort, design effort, company thought is put into getting a new system running versus being active in a market. And so your energy is looking in instead of out, and you lose track and your competitors win.
It's interesting too that iteration also has an additional cost as well, though. Like if you think about it from a DevOps or like operational space, right? If I'm strangling off features to move on to another thing, I still have to keep that legacy system that I am moving away from resilient and reliable, right?
Yeah. You're going to run two things no matter what, but at least one, you get some value back to the business quicker.
Yeah.
Ever work with a consulting firm that felt like all meetings and no momentum? Yeah, we hate that too. At Focused, we're consultants that actually build software. If you want visible progress in week 1 and every week after, go to focused.io. Let's get back to it.
All right, so I'm going to share a couple of scenarios, and we're going to talk about how we handle them. So these two scenarios are fictional, but they're about products that we all know and maybe love. I don't know, but I'm going to go ahead and read this. Okay. So for scenario 1, this is going to be Slack is our
target.
Our target, yeah. Okay, let's imagine that Slack originally built its desktop app around Electron and a tightly coupled monolith, optimizing for explosive early growth, not maintainability. Years later, the app serves millions, but even tiny updates like tweaking emoji reactions triggers cascading failures in other parts of the app. Engineers are afraid. They dread touching legacy modules filled with outdated frameworks and undocumented hacks. Meanwhile, faster native competitors threaten Slack's enterprise customers, and leadership demands 50% better performance within 18 months. Wow. Now the team faces a tough choice: commit to a risky resource-intensive rewrite that might derail new features, or keep slowly refactoring, risking missed targets and customer churn. What would you do? And that's those constraints are wild. 50% better performance within 18 months.
It's an OKR. You're supposed to get like 70% or something. All right. So up on the screen, we have a picture of my garage. And every time I go out to that garage, I do woodworking. I love it. You could see my garage is full of tools. I am terrible at putting my tools away. Like literally this like just pile up on the tool benches, put into shelves, shoved into random drawers. And like every time I do a woodworking project, I am like swearing under my breath that I can't find anything and it doesn't work and I don't know where the screwdriver is, and I swear that my wife took it, but honestly, I just put it someplace else. Like, it's like takes me forever to get these projects done. And the reason is I made that bed.
Yeah.
And so
nobody blame but yourself.
I have no one to blame but myself. I didn't put my tools away. I didn't take the time to get my workshop in a place where I can work. Like, you know, a good chef cleans the kitchen while they cook. A good woodworker puts away their tools when they're done with them and like puts them in the same place. And a good software engineering team builds in testing, automation, and architecture that decouples the business from the frameworks that they choose, and and tests that allow them to change. And so when I get to a state where, you know, we are a victim of our own success, which is awesome, and yes, we're making these bets and all that kind of stuff, like that's the hard place. It's like I've made a bunch of bets, and maybe I underserved my refactoring, maybe I didn't write the tests I did or I needed, and now we're at a place where we need to do a rewrite or we need better performance. Like, could I have done better looking back? Probably.
Right. Should
I put those tools away? Probably.
Yeah, probably, yeah.
Yeah, I mean, this goes back to design moving fast and breaking things, right? Like Slack as a company, if we're thinking, you know, they move fast, they just built whatever was needed to deliver value fast, and now you're in this situation where, you know, it's really hard to even deliver like the smallest piece of value. And usually what happens in this scenario is design always wants to advocate for a better user experience, but then you'll get pushback from engineers in this situation because they're like, yeah, that's going to be difficult to do, right? Like you're always having these, like it just creates more tension within the team as well, because engineers and designers are always in a standoff. Designers don't understand why engineers can't implement such a simple feature, and engineers are frustrated because the designers don't understand all of the implications of that to implement that design, right? So it's would you advocate for a rewrite? I mean, at this point, like you would, going back to Austin's point, you know, you could still do that carve out a piece of it, improve it, and then see if you can turn this to be more modular and improve it that way. But I just wanted to call out like a side effect of something that goes before a rewrite is this team tension.
Technical debt is like one of those terms that's pretty controversial in some circles in software engineering, but we all face it. And then the decision to pay that debt down, if you do subscribe to the idea of technical debt, the decision to pay that debt down and to remove it, you know, it's like a massive credit card bill. Like if you're not paying it off every month, like you're going to be spending a lot of time and a lot of unnecessary resources to make that better.
Two things about one, I love the debt metaphor and it's spot on, because like most people or a lot of people don't understand that debt is super valuable.
Right.
We buy houses with debt. We build businesses with debt. We use debts to like leverage up our existing like capital resources to do more with them than we could have with just just what we had. And technical debt is exactly the same.
Yep.
I can make large technical decisions. I can lever up the capability of my system at the cost of having like an interest payment. And that interest payment is the cost of productivity, the cost of potential rewrite, the cost of those things over time. So in one way, this Slack scenario is like, hell yeah. Like
right.
they used debt appropriately, and now they're as a victim of their own success. Like it is now time to pay that loan back.
Yep.
And so there is some point where like you go to a CEO and said like, look, as a technical team, we took out a lot of debt, and you know we're crushing it now, and it's time to go pay back the loan. Now the question that I think the ultimate question, and I love the debt metaphor, is like you can pay loans back in a lot of different ways. One, you just like never pay interest and then eventually make like a balloon payment. Or not a balloon payment, a bulk payment, sorry. Or you can like get on an interest only payment plan, or you can start paying interest plus a little bit of principal. And so like that's the conversation that technical teams should be having. Is like, cool, we used debt effectively, we got successful, we found, you know, app is killing it. Now how do we want to pay off this debt?
Right.
Do we want to spend 6 months doing a rewrite? Do we want to make one team focus on performance for the next 18 months and they're like the interest payment? Do we want to make, two teams focus on performance and one on replatforming over the course of, the next 18 months, and that's interest with a little bit of principal? It's like there is a way to talk about this in a really productive way, and technical debt is like, yeah, that's the right way to talk about it.
I think I love that metaphor as well for debt. I'm going to talk about it from a design debt perspective, right? It's the same thing. You move fast, break things. Debt is leverage, right? It allows you to move fast. It allows you to experiment. It allows you to do things that in like a traditional process would have taken, longer, right? You can validate things, move fast, break things. But yeah, that debt has to be paid down, even from a design perspective. Now, in this scenario, what you're talking about, the debt is the user is going to suffer, right? Because every hurdle or friction that the user goes through can be resolved easily because you have this debt you need to pay down, right? It's the same thing.
Yep.
I mean, what do they say? Like, people who are actually really good with money use debt to make more money. So, right?
Yep.
All right.
And good engineering leaders should use technical debt to get features out faster.
Exactly.
But they have to understand when they pay that debt back.
Yep.
Yeah, totally. Scenario 2 is Spotify's recommendation engine. Spotify's personalized recommendations initially ran on a complex Python-based microservices architecture, rapidly assembled during their early hypergrowth. Over the years, engineers layered experimental ML models and A/B tests on top, creating a tangled web of services with inconsistent data pipelines. I have lots of questions about that. Today, updating even a single recommendation algorithm means risking downtime or degraded user experience across millions of listeners. Complicating things, Spotify leadership demands cutting latency in half within 12 months to counter Apple Music's faster loading recommendations. The engineering team is split. Should they incrementally refactor the existing chaotic system, potentially missing critical performance goals, or commit to a full ground-up rebuild that could stall innovation for over a year? Refactor or rewrite? Yeah. Again, I don't think that's real. I think this is all fictional.
I don't want to pick on Spotify.
I mean, I don't want to. Yeah, you don't want to make Spotify angry. I have
Also, rate us really well on Spotify.
like a great way to get banned from Spotify is talking about this right now. But yeah, refactor or rewrite.
What would I do? I would start with observability. I think observability gives you a really nice place in a system to understand how different components are interacting. I also there's so many open doors in this scenario, and I know we probably ChatGPT generated this. It's a nice place to talk about all the angles, because it kind of is how an executive would come to an engineering team. We need to get latency down. I would probably ask design, is there a way to reduce perceived latency? I would probably ask engineering, where are the most latent systems? Is there caching or can we integrate intermediaries that would make things feel faster but not actually be faster? And is that a way to get into a true refactor, increase user value perception of the system versus going to a full-on rewrite? I don't know.
What do you think, Shahed?
I think there's also a couple of other implications here. We're assuming that, is latency a big enough factor for people to switch over from Spotify to Apple Music, right? There must be there's things like being locked into a system. I mean, all your playlists are there, all of your favorites are there. I think there's more to this scenario, but if we're just, for the sake of argument, if we're just thinking about latency, I think Austin's idea of perceived latency is a good one.
Slap a loading bar on it.
Yeah, just put a loading bar.
Yeah. What is it? Well, they always say, if you have a programming problem, use a regex. If you have a design problem, use a modal.
Use a modal, exactly.
I do want to tie those two together, though, because I think it's something interesting that you said, Shahed, which is you both advocated for grabbing empirical data. So you would ask users for user experiential data. Observability gives you empirical data on what the system's actually doing. So what we're trying to say is that this scenario needs a lot more information before we can actually make a recommendation.
But it does, but I would not commit to a full ground up rebuild that would stall innovation for over a year. Right. I think that you can find ways to increase value. Right. And if they're already lagging behind Apple, in this scenario, which is made up, if they're already lagging behind Apple, then stalling innovation for a year is probably a bad call.
Right. Yeah. I mean, there's some gems in here too, like updating a single recommendation algorithm, risking downtime or degraded user experience across millions of listeners. I mean, you never heard of a blue-green deploy, right? A/B test deploy. Like, what are your pipelines doing, right? Can we do incremental rollouts? Like, so sorry to knock on you so hard, Spotify, but remember, this is a fake scenario. So.
Yeah, it's a fake scenario.
We're not just in your ears, we're on your screen too. Every single episode of this show lives on YouTube. Just search /deploy, hit subscribe, and tap the notification bell. All right, let's get back into it.
All right, we're going to do a new section. This next session is keep it or kill it. All right, so I'm going to throw out a practice or methodology, and we're going to, keep it or kill it. We'll go around. Let's start. Microservices for legacy apps, keep it or kill it.
Meaning like refactor, kill it.
Really? I was going to say keep it.
Really?
Tons of nuance in this, but like microservices are like way too small, way too hard to manage. I think like it became this like super cool thing for everybody to do. It sold a ton of, serverless infrastructure to a whole bunch of people, which is great. I think refactoring legacy apps into services or carving out discrete services in a legacy app makes a ton of sense. And you should be able to do that by understanding the interfaces inside of the application and like carving out like a whole, but I would carve out a domain rather than like a microservice.
Sure. All right, Shahed, it's time to defend yourself.
I don't know. I was just gonna. I was being contrary as a designer.
That's a hard one to defend. Microservices are extremely challenging. I think in the context of a legacy application, I don't know. We've talked before about how that context is king, right? And being able to understand that context. And then you're trying to break up the microservice. You're breaking up a monolith or some legacy application into a domain or a context that you don't understand or know. Like, come on, that's not going to work. That's a recipe for disaster.
So I think you can watch the communication over between components. You can use good observability to do that.
Right.
Watch how a component, so say your auth component talks to your payments component or something like that. And they could be inside of a giant monolith, but you still have like method calls, classes, interfaces, all those types of things. You watch those communication and then you reproduce the interface and you could carve out the component into a service. I think it used to be a lot harder of an argument to win, and it's getting easier and easier, which is like microservices are really, really hard. You introduce a ton of other problems and complexities into a system when you add like networking and latency and independent deployability of the microservices. And because they're so hard, I walk into a lot of microservice architectures that are run like a monolith.
Yep.
You cannot deploy each service independently.
Right.
Like the whole thing is stateful based on one big set of state. The calls are synchronous and moving through the system as if it was a giant function call, but it's just deployed on its own server.
Right.
And like then you've kind of created the complexity, not gotten the value of microservices. So like kill it. Don't do them. Don't do microservices. Just create a service, one, and then create another one. Don't do microservices.
Feature flags on legacy code, keep it or kill it.
Oh, I love it. So let's keep it, right?
Yeah, okay. You love it, keep it. You usually keep the things you love. So
most of the time, and if they really love you, they'll come back. It's the same as like what I was saying on the microservice kind of conversation, but like using feature flags, you should be able to like carve out specific sets of parts of a system. It also allows you to A/B test. Feature flags can be a ton of things, but they allow you to turn on and off small parts of a system, including old parts, and then turn on new parts, kind of while the system is running, which makes it really easy to iterate.
Yeah, I was going to say the same thing. Keep it. We've seen on projects introducing feature flags to test A/B test features. Basically, like we've seen without affecting the rest of the system. We've seen a massive increase in better user experience. So we can actually see where the users are getting stuck or moving faster. Like it allows you to get like a really good view on the user experience.
Yeah, I say keep feature flags. Like now, if only we could kill environment variables that cause 90% of outages. All right, we'll move on. Lift.
You don't like an 800-line M file?
No, I do not. All right, let's move on. Lift and shift cloud migrations. Ooh, keep it or kill it.
I'm gonna pass on this one.
Lots of opinions.
Because I won so well on the first one. Kill it.
Yeah, kill it. 100% kill it. Like, if you are contemplating a shift to the cloud today, there better be a really compelling reason why. I can't really think of one off the top of my head. I don't know. I think the day of that kind of lift and shift to the cloud, I think it's running its course, frankly. And I think there's actually a pretty big move to on-prem, people running their own services and servers. I mean, we have lots of places that are doing that. And I think, especially in the context of data as your gold mine, right? When you hand your data over to a third party, I don't care who it is or how good they are, you got a problem.
Yep. So I think the cloud migration lift and shift business is phenomenal. Kill it because often, and I'm saying it from an engineering perspective, maybe there's other reasons. Often like a cloud migration is a financially motivated decision.
Sure.
So like we have a data center, we have to like take on all this capital expense, we buy servers, we build a building, we pump, cooling into it, we depreciate all these assets over a course of time. Or I can like move into Amazon,
right,
or Azure or Google or whomever, and then I can push a significant amount of that capital expense into an operating expense. And then there's in theory, I could dynamically scale my system. So I don't have to build a data center that will handle my scale for the next 15 years. I can just let Amazon I just add servers as needed. What I think people have found is in practice, like the dynamic scalability tends to be significantly harder.
Yep.
The provision system, the cost of the cloud is significantly higher than on-prem, especially for baseline workloads. And so they want to run baseline workloads in on-premise or owned data centers, rented leased space in a data center, and then run dynamic workloads in the cloud.
Right.
But that doesn't mean lift and shift. That means
right.
Being intelligent about the value of, cloud's dynamic nature and on-prem's like static nature, and understanding how those can both make your business better. Don't just shift things to the cloud because it's
cloud. I mean, if you're still running on-prem, there's probably a pretty darn good reason why you're still there. Yeah. So why would you unnecessarily shift? And then to your point, there's no problem with doing like a hybrid deploy. Are you going to argue with me?
No, I'm not going to argue with you. I was going to say, have you seen like the 37 Signals guys? They published about how they moved off of it. They're saving millions and millions of dollars by moving their static workloads or their baseline workloads back into on-prem. Yep. And they own their computers. I mean, yes, they had to do some other stuff. Yes, they had to go rack systems, but like at the end of the day, all of that cost added up was substantially lower than having, terabytes and terabytes and petabytes of data up in S3, which is just like outrageously expensive, or running their, running Basecamp in the cloud versus on-prem. Yeah.
All right. Polyglot architectures, keep it or kill it.
You coming in on this one?
Yeah, I'll come in on this one.
Cool.
I'll say kill it. This is from one experience, like where I was working on an Angular project. The rest of the team was on React, and it was painful. I just had to keep up with. We tried convincing the team to move from Angular to React, but it just didn't work. And keeping designs in sync manually between two different frameworks is extremely difficult, and it just creates like even from a user experience perspective, like things, you can fake the visual design of it to a certain extent, but the experience still is quite different. So it just for the sake of consistency, for the sake of creating that user experience that feels smooth, it's not possible with multiple languages.
What do you think?
What do you think?
I say keep it, and the reason why is because it's not going to matter in the near future.
Well, with AI.
I really don't think it matters. At some point, it's going to be whatever you type into a chat box. So you can keep it.
I would say, like, keep it, but with extreme caution.
Yeah.
And so, like, sprawl, we talked a lot about technical debt. You use debt as leverage to build faster. Sprawl is a tax.
Right.
And so, like, sprawl in terms of languages, frameworks, operating systems, clouds, all of those things are tax that come into your company. And so, like, I mean, like, if I have, a small Python service that uses LangChain to do something, and then I have a Rails app that communicates with it, that's a great decision.
Right.
And I think, like, do that, because, like, you're not going to build a LangChain AI app in Rails, and you're not going to rewrite your whole Rails app in Python to be one language.
Sure.
But, like, do it with, be polyglot with purpose, rather than like, oh, our developers really have been trying to figure out Elixir, and so we're going to try that next. And then our developers have been trying to learn this new framework, and so we're going to do that next. Like, that sprawl is a tax that will eventually just, like, wreck productivity.
It'll wreck productivity, and it erodes the culture of your engineering team to just constantly chase that stuff. I just don't think it's useful. Okay, the next one is dedicated refactoring teams. Keep it or kill it. I have opinions on this.
I have a slightly different take. I'm going to talk from a perspective of design systems, which I think is sort of like a refactoring team.
Sure.
I mean, obviously for me, it's keep it. Like if you're talking about design system teams, because I mean, they do bring structure and logic to the user experience, right? Like where design kind of moves. We talked about design moves like way far ahead, like showing the vision and defending the vision. Design system teams, along with engineering teams, bridge that path from where they are to that vision.
I say kill it, because you should always be refactoring. And it should be an intrinsic part of the software development lifecycle. So to dedicate a resource for that kind of smells like a dedicated QA team to me, which you should always be testing, right? Yeah. You should always be doing QA. So I think in certain scenarios, they make a lot of sense to leverage that. And, some places really do need a QA team, but it's not as prevalent as it used to be.
Yeah.
Right? And so I say kill it.
I'm a keep. So in my house, I have three boys. Then they're all 4 years old or younger. I am cleaning all the time, every day. So is my wife, cleaning all the time, every day, just to keep the house alive. And we have a cleaning crew come in every 2 weeks.
Yeah.
That cleans the house. That is like, even if engineers are doing their job and testing everything and following like great pattern practice architecture, everything, there are times where you've made a conscious decision to like not, I mean, in the metaphor of my house, like not put the toys away because I just want to go and play with my kids for a little longer.
Right.
Or like not, mop the floors today because I would rather be doing this instead. So engineering teams make that same decision with technical debt.
Sure.
And so refactoring teams are a tool that you pull in. They're your cleaning crew to go pay down your debt in a targeted way. And they can be on a timeline, like my cleaning crew comes in every 2 weeks, or they can be on a as needed basis. Like, oh my gosh, we're having the whole family come for Christmas, so we're going to bring the cleaning crew in to do that. Like, oh, we have a big push that we're doing, so we need to refactor the system. I'd keep them.
Cool. You've convinced me. Keep it.
On the next episode, we're asking the big question: how much of software development will AI actually take over? From pair programming to full-on code generation, we're breaking down what's hype, what's real, and what's coming fast. If you build software, you won't want to miss this one. Hit subscribe, and we'll see you on the next episode.
Remember to respect the craft. Evolution doesn't require chaos, and teams will always beat heroes. Cheers.